All right, lesson 3-4, dividing polynomials. So example 1, we're going to use long division to divide our polynomials. Okay, so we're going to have the ability to use long division or have the ability to use synthetic division to divide. Okay, so what we see here is we remind ourselves that we have what is called the quotient, which is what comes after dividing. So we're going to call this the quotient. Okay, this is the divisor over here. It's what is being divided, right? The dividend, okay, is what we're going to refer to as the polynomial that is being divided, right? It could be a polynomial, it could be a number, whatever. But we also need to recall that essentially we're taking the dividend, we're dividing it by the divisor, and then whatever's left is what we call the quotient. Okay, and we remember that one thing we need to recall is anytime that we get a polynomial, we want to replace any missing terms with 0. Okay, so we're going to come across that here in a little bit. Okay, so what we're going to do is we're going to arrange the terms in descending order. They gotta be in descending order, right? Both the divisor and the dividend. Okay, so we're going to divide the first time in the dividend by the first term in the divisor. Okay, this will be the first term in the quotient. And then we're going to multiply every single term, every term in the divisor by the first term in the quotient. Okay, then we're going to write under the dividend with like our terms lined up, right? So just like you would with anything that we are divising, right? So then we're going to subtract the product from the dividend or add the positive, okay? And we're going to bring down the next term in the original dividend and write it next to the remainder to form a new dividend. And we're going to repeat those steps until the degree of the remainder is less than the degree of the divisor. Okay, so it sounds like a lot, but let's take a look here at our first example. Okay, so here, right, this is going to be our dividend, okay, and this is going to be our divisor, and whatever is going to be left is going to be referred to as our quotient. Okay, so we're going to write this like we are dividing, right? So we have ourselves our dividend, which if we look closely, we got x to the power 3, we got an x squared, an x, and then a constant. So it does already go in descending order. Okay, so we got x to the third plus 5x squared plus 6x plus 9. And this is going to be our divisor, right? This is what we're dividing this dividend by. Okay, so what happens is we want to think of this as, we're going to line this up, right? And so we recall that our goal here is first and foremost, we're going to start off with the x, and we're going to see what do we need to multiply the x by to get x to the power of 3. Okay, so we're trying to figure out x times what gives me x to the power of 3. And we recall that x times x squared is x to the third. So we're going to multiply by an x squared, okay? And we're going to multiply the entire divisor by x squared. And we're going to put that below x to the third and this 5x squared. So we're going to get x squared times x, which is x to the third, and then x squared, we're going to take x squared times the 3 as well, and we're going to get a plus 3x squared. Okay, and we're going to subtract that, right? So step 3, we multiplied every term by the divisor, by the first term in the quotient. Okay, and then we are going to line it up underneath, and now we're going to subtract the product from the dividend. Okay, so we know that our x cubes are going to cancel out, right? And we're going to be left with 5x squared minus 3x squared. So we're going to get a 2x squared. Okay, so we completed step 4, right? The subtraction part. Now we are going to bring down, okay, we're going to bring down the plus 6x. And we're going to create a new dividend that we want to multiply this x by to get a 2x squared, right? So now we're thinking to ourselves, okay, what do I need to multiply x by to get a 2x squared? Well, we need to make sure that we multiply it times 2, and to go from an x to an x squared, we multiply it times x. So we're going to get 2x squared. So we're going to multiply every term by 2x, okay, a positive 2x here, and we're going to get 2x squared for the first one when we multiply 2x times x, and then we got to take 2x times the 3, and we get a plus 6x. Okay, and what happens is when we subtract, these cancel out, both of them actually do, and we're left with 0. So what that means is that when we bring this 9 down, right, this would be plus 9, we said we go until the degree of the remainder is less than the degree of the divisor. So technically, right, when we talk about a constant, okay, we go from x cubed to x squared to x, technically that's to the power of 1, right? And then this is technically x to the power of 0, which if we know x to the power of 0, or a constant, its degree is less than x to the power of 1. So we will call this the remainder. Okay, so this is going to be our remainder. And what we find is that our quotient, okay, is x squared plus 2x. And then what do we do with the remainder? That remainder goes over the divisor. So this would be plus, because this is a plus 9, it would be plus 9 over x plus 3. Okay, so let's try another one. All right, so now when we take a look at this one, this goes directly from an x cubed to a constant, right? So what we're actually doing here is we're still going to be dividing, but we have a couple of terms missing, okay, when we go in descending order. This is already in descending order, but now we got to be careful because our highest exponent is at 8x to the third, right? And we said, right, up here, replace any missing terms with 0. So there is no x squared, right? There's no x squared here, and there is no x. So it would be plus 0x squared plus 0x plus 27, right? Because they are not a part of it. So we're going to approach this just like we did on the previous one. Okay, we need to figure out 2x, right? We're going by that first term, remember. 2x times what gives me 8x cubed. Now, if we're having trouble figuring out what to multiply by, you can always divide it, right? You can take 8x cubed divided by 2x, and that's going to be left with giving us 4x squared, right? There's 3 x's up here, 1 down here. You can cancel out 1 at most, right? So we're left with 2 here. The x in the denominator is now gone. So we want to multiply by 4x squared. Okay, and we're going to multiply each part of our divisor by 4x squared. So we're going to get 8x cubed, and then 3 times 4x squared is plus 12x squared. Okay, and we're going to subtract it. So when we subtract that, our 8x cubes cancel out. But now remember, we're taking 0 minus 12, so this would be a negative 12x squared. Okay, we're going to bring this next term down. Okay, and then once again, we're going to figure out what do we need to take 2x and multiply by to get a negative 12x squared, right? So we know that if we multiply 2x times, right, times some number, we're going to get negative 12x squared. So once again, we can actually divide what we want by 2x. Negative 12 divided by 2 is a negative 6, and then we're going to be left with 1x, right? Because we've got 2 on top and 1 in the denominator. So this is going to turn into a power of 1, and that cancels out this x. So we're going to multiply by a negative 6x. Okay, so we get negative 12x squared, and we're going to get a minus 18x. So now remember, we're subtracting this, right? So that's going to turn, what's going to happen is this is going to turn it into a positive, right? So if we want to change this, right, we can distribute that negative, or so we're subtracting a negative 12, which turns into a positive 12, and that's going to cancel this out. And then we're taking, we got to be careful, we're taking 0 minus a negative 18. So that's going to turn into a positive 18. Okay, we're going to bring that 27 down, and we're going to continue the process here. We got 1 left. Right, now we're saying what do I need to take 2x times to get an 18x? And we see if we take 18x divided by 2x, the x's are going to cancel out, and we're going to be left with just 9. So we're going to multiply by a positive 9, both terms. So we're going to get 18x here. Remember, we're going to be subtracting it, so 9 times 3 is 27, which means we get a 0, right? And remember, this is our remainder. And if we have a remainder of 0, that means that we do not need to worry about anything. Okay, that means that we have factored it completely, and the quotient is 4x squared minus 6x plus 9. Okay, so we're going to get our quotient to be a 4x squared minus 6x plus 9. And once again, since there is no remainder, we don't need to add 0 over 2x plus 3. We can just leave it as this, and we're done. Okay, so that is long division. All right, that's long division. So the other method that we're going to learn about as well is what is referred to as synthetic. Okay, synthetic division. So synthetic division is the method used to divide a polynomial by a linear expression in the form of some x minus a. Note that the leading coefficient of the divisor is 1, and a is the 0 of the divisor. So that tells us that we're going to divide it slightly different. Okay, and there's a little bit to go along with this, a lot of things that go on, but to divide by some x minus c, right? We can only do this with some x minus c. So the x, this value in front of x has to be 1 in order to use synthetic division. Okay? And so anytime that we have a leading coefficient, like up here, this is a 2x, we want to be thinking of using long division. Okay? But when it's just 1, it makes it really easy. Okay, so we're going to write c for the divisor, x minus c, to the right, and we're going to write the coefficients of the dividend. Okay. Now we're going to write the leading coefficient of the dividend in the bottom row, and then we're going to multiply c times the value that was written in the bottom row and write the product in the next column. Okay, we're going to add those values, and we're going to continue summing it up until we figure out whether or not we have a remainder. Okay, so this is kind of like before, and we're going to use synthetic division to help us solve. So in this example, right, since this divisor is x minus 3, that means that the value of c is a positive 3, right? It's it's the opposite of whatever this sign is. So since it's minus 3, this is going to turn into a plus 3, okay? And that means we're going to set it up like this, right? So 3 is our value of c, okay? And then what we're going to do is we're going to write all of the numbers below here, the leading coefficients. Okay, so the leading coefficient of some 2x cubed is just 2. So we're going to grab a 2 here, we're going to grab a -7 and the -4. And notice that this one, it's missing in x. So that means we're going to put 0, there's a 0x there, so we're going to put 0 when we get to x. Okay, so we're going to just put the leading coefficients down. That's 2, right? -7, 0 for the x, and then -4. Okay, so this is, remember, our x cubed, our x squared. This is our x, and then this is our constant. Okay, at the end. And so what we want to do is we're going to bring the first one down, and instead of subtracting, we're going to be adding, right? So we get a 2 here, which means this is going to be our x squared. Okay, this is going to be our x squared. So that means that, notice, this is x to the power of 3, and when we bring it down, it turns into an x squared. Okay, so it's always going to be, the power is always going to be 1 less than what we had originally. So we started with 3, we brought the power down 1, so we got an x squared here. And what we're going to do is we're going to take this 2 down here, and we're going to multiply it times the 3. Okay, so 2 times 3 is 6. Whoops, we get 6 here. And then what we're going to do, like we said, it is addition. So we're going to add these 2 together. We get a -1. And now this is our value, our coefficient for x. Okay, we're going to do the same thing. We're going to take this -1 down here. We're going to multiply it times 3. And we're going to get a -3. We're going to add these columns now for x, and we're going to get a -3. So now this is going to be our constant. Okay, and so we need to figure out whether or not there is a remainder. So we're going to multiply -3, -3 times the +3, we get a -9. And when we add them together, we get -13. So this is our remainder r. Okay, so when we write out our quotient, okay, our quotient is now going to be, our quotient, or our answer, right, is going to be a 2x squared minus x minus 3, okay? And then we have this -13 as a remainder. So remember, we put that over, we're subtracting, not adding, we're subtracting 13 over our original dividend, which is x minus 3. Okay, and that is going to be synthetic division. Okay, so it's a little bit different, but remember, we only want to use this one when our dividend, the value of x here is the coefficient in front of the x is just a positive 1. Okay, and what we can do, whether it is with synthetic division, or with our long division, whatever the remainder is, we can figure out whether or not that a polynomial is the remainder. So the remainder theorem states that if a polynomial is divided by some x minus a, the remainder is p a. So we're going to plug that value of a into the function. We're going to use direct substitution. Okay, so I'm going to show you what I mean by that. We're going to do synthetic division again. Okay, so this here tells me once again what my value of c is, right? Just like up top, we had a minus 3, so therefore c was a positive 3. Now we got a minus 6, which means c is a positive 6, and we're going to use synthetic division. So this is going to be our value of c here again. Okay, and when we look up here, this is in descending order, right? We have an x to the fourth, an x to the third, x squared, x, and a minus 6. So we have all of our terms here in descending order. So we can put a 1 here, right? Because remember, that's an invisible 1 in front of x to the power of 4. Okay, and we're just taking down all of these numbers below. So we got minus 8, 16, a negative 23, and a negative 6. Okay, so we're going to bring this first one down. Remember, we're going to multiply by the bottom, and then we're going to add. Okay, so this is a positive 1, and recall that since this was x to the power of 4, this is now x to the power of 3. Right? It's always going to be 1 less. So this will be x squared, x, our constant c, or our constant, and then this is going to be our remainder r. Right? Because this was x cubed, x squared, x, and our constant in the original polynomial. Okay, so once again, we're going to take the 1 times 6, we get a positive 6. We're going to add them together, we get negative 2. We're going to take negative 2 now times a positive 6, we get negative 12, and we just continue the process multiplying this number down here times the value of c. So we get 24. This is a 1. And then 1 times 6 is 6. And when I add them together, we get a remainder of 0. So we get x cubed minus 2x squared plus 4x plus 1. That is going to be our quotient. Okay? So we're going to prove now that this does divide it. Okay, it does give us a value of 0, and if this is a 0, remainder of 0, going back up to the factor theorem, it states that x minus a, or in this case x minus 6, is a factor if and only if the value of p of a equals 0. So we're going to prove that using direct substitution now. Okay, so we're going to take our original equation, right, which is p of x equals x to the fourth minus 8x cubed plus 16x squared minus 23x minus 6. And if we plug in the value of c, right, that positive 6, remember it's the opposite of what we have here. If I plug in and find what p of 6 is, if we plug 6 in, whoops, sorry, this is minus 8, minus 8x cubed. If we subtract minus 8 times 6 cubed, add 16 times 6 squared, subtract 23 times 6, and then minus 6, if we plug all this into a calculator, we're going to get 0. So that tells me that x minus 6 is a factor. Okay, if we get anything other than 0, then it is not a factor. Okay, so if you want to take a look, I would try and do another example here. We're going to take a look at one more example just to make sure that we have this down. And then you guys can try the lesson check after and check it on the Key Online. Okay, so we're going to do the same thing here. We're going to use synthetic division, and we can use it because this is a coefficient of 1, right? So here, since this is a positive 3, that means C is negative 3 now. Okay, and the other thing to consider, remember, this is in order, but between x to the 5th and minus 5x to the 3rd, we're missing an x to the power of 4. So that means it's going to be 0x to the 4th. So our C is negative 3, right? We get a positive 1 for x to the 5th, 0 for x to the 4th, minus 5 for x to the 3rd, positive 9 for x squared, minus 1 for x, and then positive 3. Okay? And we don't need to put the plus there. So we're going to bring that first one down again. Okay, we get 1. And I'm going to just multiply as I go through. So minus 3, this is negative 3. Negative 3 times negative 3 is 9. Add them together, we get a positive 4. 4 times negative 3 is negative 12. Add them together, we get negative 3. And when I multiply those two, I get a positive 9, which is 8 when I add them together. And then we get a negative 24. So add them up, we get negative 21. So remember, this is now x to the 4th, right? Because it's 1 less than the original, and we just continue on. So we get x to the 4th minus 3x to the 3rd plus 4x squared minus 3x plus 8. And then remember, this is our remainder of negative 21. So we're going to put that over, right? It's not a plus 21, it's a minus, over x plus 3. And this is going to be our quotient after we use synthetic division. So we're going to prove, now once again, we're going to plug in negative 3 into the original function, and then we're going to prove that it's not a factor. Okay, so doing direct substitution, when we plug in p of negative 3, we're going to get negative 3 to the power of 5 minus 5 times negative 3 to the power of 3 plus 9 times negative 3 squared minus a negative 3 and then plus 3. So when we plug that in or work it out, we're going to get a negative 21, and that proves that x plus 3 is not a factor. Okay, so just to make sure you got this down, all right, what you want to do is you want to make sure that you take a moment, okay, and try the lesson check. Try 1 and 2 on your own, okay, and then check the key to the notes, and you guys should get some answers. If not, make sure you bring those questions tomorrow. Okay, have a good one. Take care.